This time, we will review the construction of River Abu Dhabi in order and continue to present the dome support tower, the temporary steel tower, and the dome. First, let's look at the overall construction order. I'm going to show you as schematic diagrams. The site where the River Abu Dhabi was built originally shared both sea and the land. Therefore, broad stones were stacked above sea level to build lakeside. After that, the interior space was filled in to create a workspace. Of course, it's in contact with water, so it's a hydraulic barrier. A deep well point has been installed to remove moisture. If we look these in cross-section, we can see how they responses to the site. After the moisture was removed, 53,000 cubic meters of sand was removed from the site area of approximately 24,000 square meters by the designed underground depth. And they installed 40 to 98 steel piles and 1340 concrete by MIP method. However, due to the economic crisis, the construction was suspended for a while, and after the construction was resumed due to water penetration, the first double waterproofing was installed to cover and protect the entire building. The material of the double waterproof film is as follows. The concrete pile is also waterproofed, and the method is as follows. Afterwards, construct a reinforced concrete draft slab at -7 meter level. Construct a reinforced concrete draft slab at -3.5 meter level. When a 7 meter -3.5 meter raw slab is made, the dome starts working at the same time. Among the 4 dome support towers, the first reinforced concrete dome support tower is installed. Several temporary steel towers were installed around the dome's support tower. These temporary steel towers were used to withstand the load that must be borne when the dome is installed. Afterwards, create the first dome segment. Create a second dome segment in the same way. Build a temporary steel tower between the 2 dome segments, as the current support structure alone cannot withstand them. And then you start making the top part, and you start making the 0 meter draft slab in the dome structure that has been carried out so far. The temporary steel tower is removed to secure the workspace under the dome. After that, the other 2 domes support towers. Install temporary steel towers as needed and make them in the same way. The shape of the dome is created as it is today. Now create the 4 rim segments to complete the dome and remove all temporary steel towers. When the tower is removed and space is available under the dome, buildings are built and water is brought into the site. Unlike other buildings that use piles, this building had to consider floating condition because it introduced water after construction. Therefore, the 25 foundation pile, which was first supported in the early stage of construction, serves as an anchor. 280 underwater tension pillars around the edges of the River Abu Dhabi kept them from floating. First, the mock-up test of the dome.
On top of this foundation, the River Abu Dhabi building was built. The first to be built is the dome, the symbol of the River Abu Dhabi. This huge dome structure at the core of the design concept performs environmental, aesthetic, and structural functions. Environmentally, it provides shade and cool temperature in the interior space of the museum. Aesthetically, the dome functions as an outdoor canopy. It filters the sun's natural light through a hole in the ceiling and creates a lightning effect under the dome. Structurally, the dome spans 165 meters between the four supports, creating a huge cantilever. The pattern of the dome comes from arabesque as a traditional Arab pattern. This basic geometric pattern consists of isosceles triangles that are repeated and rotated to form a system consisting of squares and hexagons. To create a dome with this pattern, a 1/33 scale model of the entire dome was fabricated. The 1/33 model was built primarily for light testing. This model served as a precursor to the full-scale dome structure because many problems related to construction had to be addressed. 15,280 of aluminum and stainless steel parts were used over a 6-month period to make a 5.5 meter diameter model. Initially, a basic structure analysis of the 1/33 model was performed to evaluate construction alternatives. The 1/33 model had to withstand a temperature difference of about 70 degrees. Due to the thermal expansion of the structure, the only solution available for dome cladding was to apply aluminum ALMG3 and H111, which is the same material. Though this aluminum was applied to the actual structure. The cladding was built with a small module of approximately 600 multiplication 600 mm and assembled at intervals of 0.8 mm each for thermal expansion. The process of fabricating large models to represent geometric patterns is important in developing efficient, practical, and viable solutions for their construction. The full-scale mock-up test was carried out through the large-scale mock-up tests. The space around the model was completely sealed to block the side light, and a moving platform was structured to simulate the conditions at the center and edge of the dome. The mock-up test became a good reference point for continuous reference during the design period. After completing the mock-up test, the dome began to be built.
So now I'm going to have a closer look at the dome support tower, the temporary steel tower, and the formation of the dome.
As I said earlier, the Louvre Abu Dhabi was constructed simultaneously. The dome and the tower supporting its structure were constructed at the same time. From a distance, the dome of the museum at the time of construction seems to float above the gallery. But that is because of 118 temporary towers, 500 trusses, 30,000 meters of beams, and 70,000 square meters of platforms and scaffolding supporting it until its completion. Once the finished dome has been lowered into the 4 giant steel bearings that will eventually support it, all of this infrastructure will be dismantled and recycled. About 5,000 tons of steel were used in the Louvre Abu Dhabi. The amount of steel in the demolished temporary steel tower is 3,500 tons, similar to building another dome underneath it. Among several temporary iron towers, Tower 91 is a blue whale-sized metal pillar located in the heart of the works. Its weight is 25 tons and is shaped like a giant golf club, has to be lowered both downwards and then sideways through a hole in a wall. A hole which was designed with just one purpose, to accommodate the tower for the next few months. Places like this can be found throughout the site. As well as temporary windows, giant concrete plinths have been constructed across the site just to hold some temporary towers at the concrete height. Some temporary steel towers receive a load of 280 tons at one point to handle the force exerted on the walls and floors of the museum. Towers that play an important role as shown above must be very accurately positioned to a fine tolerance of 10 mm. In this session, we reviewed the construction details of the Louvre Abu Dhabi in order and announced the temporary steel tower and dome. Next time, we will present the design of the dome as well as the structure of the dome. Thank you.